My name is Saizo. I'm one of the PBS assessors at Advantia. I'm also the general manager here. Static rollover threshold is a measure of a vehicle's lateral stability. And typically, if you want to know what your SRT is, your static rollover threshold, you'll have to come to a company like us and engage us. And it's a bit of work, and it can be expensive and time consuming and kind of complicated. So we just wanted to basically put that in the hands of industry and just make it really easy for them to calculate the SRT of their combination. Because when you know the SRT of your combination, you can know how safe you are, and that can affect how you drive and how you load the vehicles. What we've done is we just came up with a plan, and then we put it through the HVSI scheme, and they ended up awarding it. So they really saw the merits as well in having that kind of broad-based, industry-based, wide use appeal for SRT.
Payload Pilot will provide layers of information to inform heavy vehicle drivers how to safely operate their vehicles in a range of environments involving turning maneuvers. This detailed information will aid drivers to become better drivers, safer drivers, and also able to complete their deliveries in a more of a predictive manner.
Payload Pilot works by using the same software that we use for our PBS assessments. This is high-end simulation software that typically requires an experienced engineer to use. However, because of the interface that we've developed, anyone from your average truck driver up to an experienced engineer can use the interface and still get a high quality output.
We're here today doing a very important test to calibrate our Payload Pilot. We have a very common vehicle to actually do a proof of concept test of what we'll have as a simulation outcome for everyone in industry to be able to use. A single semi-trailer, 6-axle, set up to be tilted up to the safe point where it's then caught by chains, and that's basically the critical point where it would be in a simulation held back. So what we're simulating here today, and essentially sort of in a practical sense, is proving what we'll be doing with actually high-end software. So it's essentially eliminating the safety buffers that you might have in a simulation environment and proving that we have a real-world example to baseline what our results will be that we're providing through simulation.
So today we're collecting a lot of information, because a lot of information actually goes into determining what the static rollover threshold is of a combination. So we've measured things like the heights, the payload mass, the tare weights, all of that, the suspension, the running gear, things like that. And so we've collected all that information, so when we determine the static rollover threshold today, we can then put that same information into Payload Pilot and make sure that you're getting the same static rollover threshold out. So the simulated results are going to match what the real world results are. So we're making it really easy. Basically, it's just an online website where you can input certain information about the combination, and it's going to give you the same output that we're getting today, except also it's going to cover all kinds of different combinations. So we've got a semi-trailer, but we'll have B doubles, truck and dogs, A triples, B triples, you name it. Payload Pilot will accommodate it.
It's intended to have different layers of skill set to engage with it, so that if you want really precise information, you can get that, or if you want aggregated or averaged information, that will be available as well. Key inputs will be available for people to hone their vehicle and how they operate it, or even make choices about how they equip it. Payload Pilot, ensuring your safety at every turn.